is Sargon Lee. I'm engineer as of Envisage in Canada and most likely doing Android here. I'm here today. I'm here today to talk about Android a little bit more than what we've done in the previous sessions and possibly a little bit deeper. Although I just name it as Android in depth, I try to explain everything in this session as easy as possible. So it'll be also beneficial for those who doesn't have experience on Android phone as well. And as you know, I'm just doing this session in English, but that does not mean you have to speak in English too. So if you have any questions and if there's anything that you don't understand, just feel free to raise your hand and ask questions.
I'll try.
Yes. So we're gonna start with. So before I start, any questions? Okay.
Isn't your name Charlie?
Oh yeah, my name is Charlie Lee, but you can also call me Charlie, which is my nickname. So
Okay.
both are acceptable.
Okay.
Yes. So I'm gonna start with the Android architecture overview. The reason why I choose this topic at the first is because a better understanding about the platform and what's going on under the hood will help you to write the better applications. So that does not mean you have to memorize every single thing in those screens. Just if you can just get sense of what the key components on the Android platform, then that's enough. So Android is based on Linux 2.6 kernel. The Android uses Linux kernel as the hardware abstraction layer. The reason why they use the Linux is because it provides a proven driver model. In many cases, existing drivers. It also provides a memory management, process management, a security model, networking, a lot of core feature of the core operating system infrastructures that are robust and have been proven over the time. The next level up is Android system native library. So everything you've seen here in this box is written in C or C++ language. And this is at this level where most of core part of Android platform comes from. So I'm gonna quickly go over key components that I highlighted as orange colors. So let's start it with the Surface Manager. The Surface Manager is responsible for composing different drawing surfaces on the screens. So it's the Surface Manager that is responsible for taking different windows that is owned by different applications that is running in different processes. And all the drawings at the different time and making sure the pixels ends up on the screen whenever it's supposed to be. And besides, we have OpenGL, ES, and SGL. And those two actually makes up the core graphic libraries in Android. OpenGL is a 3D graphics library. Android actually has an implementation of the software implementation that is hardware acceleratable if device has just 3D chips on it. And the SGL are the 2D graphics library. And that is what most of applications drawing is based on. And Android also has SQLite, implementation of SQLite, which is a file-based, very light database system. Android use that as a core of most of applications storage. And then we have also WebKit. WebKit is it's an open source browser engines, and this is the same browser that is powering Safari from the Apple. And just want you to know, the things that you need to know is that after Lollipop, which is the latest Android operating system, they just abandoned it. So this is not the part of Android platform anymore. They just replaced it to the Chromium, which is the next generation of the web engines. And they're moving over, we have the Android runtime. This is what we call the Android runtime. The main components in this Android runtime is virtual machines. So traditionally, it used to be the Dolby, but after the Lollipop, it is replaced by the ART, the virtual machines. We used to have some transition period that user can choose one of those the virtual machine, but after Lollipop, the ART is the default virtual machines on the Android system. Um, the Android runtime is designed specifically for Android to meet the needs of the running in an embedded environment where you have a limited battery, limited CPU power, limited network bandwidth, like everything is limited. The virtual machine runs something called the DEX files, DEX. These are the bytecode that are result of converting at the build time classes in the jar files. So these files, when they are converted to the DEX files, become much more efficient bytecode. They can run very well on small processors. They use the memory very efficiently. The data structure are designed to be shared across all the applications whenever possible, and it uses highly CPU optimized interpreters. The end result of that is that it's possible to have multiple instances of the virtual machines. So, yes.
Could I have your attention, please? Could Felix please go to room 2? Felix, could you please go to room 2? Thank you.
So next level up from that is the core libraries. So these are all written in the Java. Oh, sorry. So core library here, this guy. So those classes are all written in the Java, and then the core library contains all this the collections and utilities and IO classes, all those like package classes you expect to use for Android development. Okay, moving up again, we have the application framework. So this is all written in Java programming language as well, and the application framework is a toolkit that all applications use. Okay, again, I'm gonna just go through the key components of these the layers, not everyone. So okay. Let's start with the activity manager. So activity manager is what manages application's lifecycle. It is also maintain a common backstacks so that application are running in different processes can have a smoothly integrated navigation experience. So if you have Android phone and any experience on an Android platform, you will have like switching between two applications back and forth and have more like smooth integration, integrated user experience. So activity manager is actually key components that make those behavior on the Android platform. Next down from there, there's next beside we have. Well, let's start with the package managers. The package manager is what keeps track of which application is installed on your device. So if you download a new application over the air or from the wired cable, like no matter where it is, this is the package manager that take a look at if the same application is already installed on your phone. So whether you need to upgrade it or like fresh installed, or the hardware you have, which actually has all those hardware features that the software requires, like the permission-related pre-checking process or like those kind of things. That's the package manager, what the package manager does. And then we have a window manager there. Window manager just simply manages the window. It is mostly Java programming language abstractions on the top of lower level services that provided by the Surface Manager down there. And we have a content provider there. Content providers are a unique piece of Android platform. That's the framework that allows you to share your application data to other processes or other applications. We're going to talk about a little bit more about those later at the end of this talk. So let's just skip this for now. And we have a view system there. View system contains things like buttons and lists, all the blocks of the UI components. It also handles things like events dispatching and the drawing, all the layout, all those like complicated, the drawing related, the logic. So final layer on top is application. So this is where all the applications get written on. So it includes the home applications and context application and browser applications, like any application you just install from the market too. So anything that at this layer is using the same applications, a framework provided by the layer below. So activity. So if you have any experience on the Android, or like even if you are interested in Android development, you might have heard of it. So activity. Essentially, activity is just a piece of UI that typically corresponding one screen on the device. So if you think of something like email applications, then the application then would be decomposed into three activities, for example. One is activities that display list of items, list of emails that you have in your inbox, and the other activity that displays detailed messages of individual messages. And the other activities that allow you to write, compose another messages for outgoing emails. So that one was all right, but after Honeycomb, so Fragment has been invented for fixing specific problems on the platform as Android moved into another devices spaces like a tablet. You're gonna see a specific screen on the application one at a time, because that's really all you can just deal with a small device, small screens on the device. But however, if you got a tablet devices, then you can just display so much more on the screen. So now, instead of having a separate activities, you have a bundled activity that has a one or more than one the fragments. Maybe all the screens appear at any given time. What they just Google team wanted it was that a way for people to be able to write a readable code, and then you could write a chunk. They can be used either in separate activity on small devices, or or put it together one activity, or just side by side as a fragment in a single activity in large devices like a landscape mode, for example. So you can think of them as mini activities. But basically, the idea is that you can have a separate unique fragments running inside one activity, then interacting together. At the same time, you can also take the same reasonable chunks and then use them inside separate activity in different device configurations. So what I mean by different configuration is not just it's not just difference between phone and tablet, but this is also about portrait and landscape with different orientations as well. Let's look at these pictures that visualize what I'm talking about. So just the left side is a tablet and the right side is a phone. So if you look at the tablet, there is two panels. So on the left side, there is a green panel that display a list of items. You can choose one of them. And on the right panel, there's all right panels that display detailed contents of the item you choose on the left. So let's name it a fragment A. So this is based on the fragment. So let's name it as a fragment A. This is fragment B. So if you run this APK on the phone, which has a smaller screens, then you can just display one fragment at a time, and then you just adapt the different screen sizes. So what you need to do is, instead of rewriting entire applications, you just write a minimal the container activity and launch another activity has only single fragments there. Yes. So these screenshots on the display came from the excellent article that is introduction from the fragment on the Android developer site. So an application usually consists of multiple activities that are loosely bounded to each other. Typically, one activity in an application specifies the main activity, which is presented to user when launching the application for the first time. Each activity can then start another activity in order to perform different actions. So this is about the activities life cycle. So if you already have the application based on the activity model, then it's relatively easy to convert it to fragment-based application, because there is corresponding life cycle in the fragment. So it's very obvious where code should go, right? You just copy. It is not just copy and paste it and you just expect to work, but it is not. It doesn't require a significant work or like significant that much code changes. So this is just display what's the life cycle between activities and fragments. So okay, to move one activity to another activity, we call activity start activity method. But note that when using start activity method, rather than specifying the class name of an activity to start directly, the class name is explicitly packaged explicitly within an intent. So whenever you need your application, your components to communicate with each other or with the system components, you need to use intent to identify the target destinations. Starting activity within your application is the simplest example. Intent that use the name of the components you're targeting directly is known as explicit intent. I'd like to think of intent as enveloped. So each one includes who, or in this case, which components you want it to deliver it to, and there is room for a small amount of data to deliver it. Primary tuples that will be available to the application components that received an open intent whenever they receive it. Explicit intent explicitly specify the name of the recipient, like that. Implicit intents are a lot more interesting. Here we don't specify the name of class, and we don't even know what it is, like that. So well, intents. Then how do we indicate which activity to launch? The intent resolution system on Android is finding an activity capable of performing an action you specify on associate data. So rather than specifying name of a class, you indicate an action you'd like an activity to perform on and on what data the action should be performed. And because intents can cross activity boundaries, the activity that started may not be part of your applications. So you can include functionality like opening the map applications and browsing website or making phone call, all from within your app without you having to implement any of it yourself. You don't even need to know about application that will serve your request. So how did the system know what the map app could handle this intent? The activity within the map applications included an intent filter, like this one within any manifest entry. It indicates the map app is capable of performing these view actions on all data which has a geoscheme. So it indicates the map app is capable of performing the view actions on the data that has a geoscheme. You can use intent filters for your activity to define an actions they're capable of performing. And optionally, the type of data they can perform it on. Android will resolve this request by checking the intent filter of every single activity that is installed on the device until it finds the best possible matches. If multiple activity are the matches, then user will need to choose one of them.
Who choose one of them?
The Android system will pop up the dialog with the list of activities that match the intent filters, and user need to choose one of them. So, yeah. What if you want to broadcast a message to many applications? So, for example, Android will broadcast a message saying that device is just charging or that it just finished rebooting. To do that ourselves, we use a send broadcast message to broadcast intent. And those broadcasts are received by broadcast receiver, typically referred as simply receivers. Using intent filter, like the one we just saw earlier, it indicates the broadcast they're interested in. So intents are transmitted to every applications with a broadcast receiver that has an intent filter telling the system they wish to subscribe. Oops. So as you can see, the receiver itself pretty simple. You just extend the broadcast receiver classes and override on receiver method here. The receivers are the very lightweight components that meant to be listening for broadcast and reacting and completely within 5 seconds. So usually means simply starting service or sending notifications. To have your receiver start listening for broadcast, you need to register it either through an entry in your manifest, like this, or dynamically one of the application components, usually an activity like this. The biggest difference between a manifest and dynamic receiver is when they are triggered. Programmatically, a registered receiver will only receive the broadcast while the app is running. However, the manifest declared receiver will start your app, your specifically launch your application to receive your broadcast. Okay. So this is adapter view. So in order to achieve a scrollable list view, you can just simply use a scroll view that contains one of the layouts. The scroll view allows the user to scroll through the contents of the layout it contains, and the linear layout, for example, it arranges the items inside, arrange the vertical or horizontal according to depending on how you define it. But there is a challenge associated with that approach. With the small devices has a limited memory. So adding every single item to linear layout within the scroll view means that every view we created stick around and take up the memory even if it's never seen. So we want to try and create a way that we only need to use as many views as currently visible on the screen, plus one on either side to make sure we can just scroll without flickering on the screen. To do that, Android uses a list view. The solution is recycling each view as you scroll off the screen, allowing it to be reused when we need to show another item as it moved into view at the top or bottom. So rather than creating and holding in a memory, we only need to do the creation step for the number of visible items on the screen, and plus a couple of more on either side. Then whenever a new listed items comes into view, we just update the data displayed on our items in our recycle pool. This recycling behavior is implemented across all adapter view descended classes, such as grid view and a list view. So, but in order to use adapter view, we have to provide adapters. By keeping them separate, the adapter view and adapter itself, your adapter define how to display each item of the underlying data, and while the adapter view implementation itself is responsible for controlling how each of these items is laid out on the screen. So this demonstrates how list view and adapter interact together. So say on the left side, this box represents adapters. And on the right side, there's a list view with the empty screen. And we create, so for example, let's just start it with the empty data, the raw data. It can be a list of items or some collections, or sometimes it can be a cursor, which is a proxy of the SQLite tables. And then we just passing into adapter, and the adapter can have a reference to it. And then adapter know how to create each view, but the adapter doesn't create every single view as much as the data exists. It creates only when the list view are requested. So say list view, at the first, when we provide adapter to list view asks how many items is available. So then now we have 3. So list view starting populating the items with index position number 0. And then the request goes to adapter, so adapter knows how to create the items first one, and then you just go ahead and just does that. So you just return the first item to list view. And then list view will draw it on the screen. And then list view keep fetching the list items until it actually it have enough the items as much as the adapter has, or until it actually fill up the screens. So we're gonna see more details about how adapter and adapter view works later. So let's just skip this like this. Okay. So content provider. Content provider is a component that allows you to share some of your data with other processes and other applications. Now, any application can store the data in whatever it makes sense for your applications. They can store it under a file system. They store the data under SQLite databases, whatever it makes sense. But if they wanna make the data to available to a platform in the other system, so other application can make a use of it, then what's the solution for it? What can be solution for it? Content provider can be the solution for it. But if you're not really planning to expose your app data, in a lot of cases you can just skip this. But you really shouldn't, because by using content provider, it's easier for you to potentially switch out the data source and much easier for someone other than you to maintain the UI layer without them having to understand the depth of your data storing implementations. If you want to interact with anything outside your application, such as sending data to widget or returning search results from your applications, you will need content provider for that too. And similarly, there's a bunch of APIs designed to optimize the process and syncing and querying data and updating UI accordingly. All of them also expected content providers. That includes a sync adapter and cursor loader, which makes your app able to efficiently sync with your server, load data in your UI layer, and which include built-in content observer that will update your UI automatically when underlying data changes. You could, of course, build all yourself. You can build all by yourself, but at a certain point, the advantage you gain by not writing content provider begin with is a loss in process of recreating all the classes you're utilizing. So let's talk about loader. So loaders are the framework, the mechanism is to generate data off the UI thread and then return them on the UI thread back. They were introduced in Honeycomb, but also available as a part of the support library. So you can take advantage of it whenever you support earlier platform release. When you create loader, it creates a sync task to load data on the background thread. And then it syncs with the UI thread when the initial loading is completed. It can be set up to monitor the underlying data and then deliver any update to UI thread as well. The cursor loader is the implementation of the sync task loader, specifically designed to query content provider, the one we saw before, and then return a cursor, which you can bind directly to UI. It will automatically update the cursor whenever the underlying content provider change based on the change to the underlying databases. If configuring change, like say change the orientations or change the language set in the settings, it will reconnect the last returned cursor after being recreated. So along with the host activity. That means that you won't have to requery data just because the device was rotated. So the cursor loader handles all of your cursor management and background thread creations, UI thread synchronizations, and data source monitoring. Even if you choose not to use a content provider, still you can take advantage of loader. But then you just need to recreate your own loader by extending a sync task loader directly. So this is roughly how loaders looks like. On the left side, this is a UI thread. On the right side, there is a background thread. So in your first interface to loader is init loader. You call init loader with loader ID, although you can just passing some values to the loader, and you're just passing the callback, which is usually implemented in the activity, either implement a fragment or activity. And that's where you create And then you got a callback from the onCreate loader. And this is where you create your cursor loader or actually any kind of loaders. And then cursor loader will go off the background thread and will do this like content provider query. The logic on the background thread is supposed to be very heavy, hit your disk, it's very like basically slow the system down, but you don't care because it is a background thread. When the query is done, it will call the callback onload finish, this one, which has a cursor over that information.
When did the loader was introduced in Android?
Say it again.
When did the loader was introduced?
Loader was introduced with the honeycombs. Yeah, it's the same time.
Okay.
Correct?
아니, 질문인데요.
네.
아니, 컨텐츠 프로바이더는 그 어플리케이션 간에 데이터를 주고받을 때 사용하는 로더는 정확히 언제 어느 용도로 사용하는
So okay, let's make it like let's put it this way. The content provider is an abstraction layer of the model. So it doesn't do really anything, but it just provides a nice and neat and organized way to share the data. But the loader is actually the abstraction is abstracted the logic between handler and some caching logic there. So basically, whenever you rotate changes, change the orientations, you're supposed to destroy the activity and recreate a view. Then if you just like hard-coded it, create another thread and create it, then you just basically loading same data, right? You just change the orientation, but the data itself is the same. But if you use the loader, it actually caches the data inside, so you don't really do fetching the data again. You use the cache data. Yeah. So this is the loader is about how to load the data, but content provider is how to share the data to other like applications. So you can load the data with the loader through the content provider. Does it make sense?
그러니까 컨텐츠 프로바이더에서 로드할 수도 있고 데이터베이스로 로드할 수 있고 아니면 네트워크 통해 가지고 로드할 수 있고 데이터 소스는 여러 가지고
Yes. So loader is about how to load data. It doesn't matter where the data comes from, but we usually use with the content provider because content provider is supposed the way we just share data and abstract how we store the data. Yes. You can call the content provider directly on the UI thread. Then that means you just do the heavy operation on the UI thread. So this is about the abstraction class about the multi-threading. Content provider is abstractions of the model. Yes. Any questions? So this is how we use the loader. Like typically how we use the loader. So first you need to do is implement the interface. And that interface contains the method, which is onCreate loader, onloader finish, and onloader the reset. And actually the data type is a generic. So depending on what you need, you can change the data type. But we usually use a cursor, and then it's just directly called any loader, cursor loader, which is a part of the Android the platform system. And then you start the loading process by calling init loader. In order to call it, you have to get a loader managers. You can call this method from either a fragment or activity. Oops. So I think I finished too fast. This is what I prepared for our first session. So any questions?
questions? Two questions actually. So first of all, you should there. I just want to see the fragment and activity screen. Actually. So in the tablet screen, there are fragment and activity on the screen, right? So what I assume is that the fragment and activity actually is inside of another activity. So is that true, or is that correct? So one activity actually includes fragment and activity.
Yes. No.
So there,
Activity cannot contain activity.
oh,
Yes.
so how they are conceived on the screen?
Okay. So each screen, so activity is just a container. You can just think of it as a container. So one activity fill up the whole screens. You can't just split the screen with activities, but you can with a fragment. So for this, there's one activity that contains 2 fragments. And then whenever you click one of the items on the left side, that fragment is going to be interacting with another fragment on the same activity. But on the other hand, if it's just small devices, but there is no interaction between fragments. But instead, you launch another activity that contains another fragment that used to be interacting together on a tablet devices. But because most of business logic here is going to be shared, is going to be implemented in the fragment. So only thing you need to do is about the navigations. But even with that code, it shouldn't be like too much. Just so by following this fragment, the model, the responsibility of activity is very minimal. It just you can just think of it as just containers, and all those view related to logic will go inside of the fragment.
So then those the two different user interface can be done with the one code.
Yes or no, depending on how you implement it. Yes.
I just understood the fragment actually can combine them together. So when some event happens, the other one triggered. But if you use a fragment, it will be like loaded together, and just instead of calling the new activity, it just display the next one.
Yeah, if you implement it that way.
Okay. So it can be ready with both the screen. That it can be ready at the same time and just display the different or whatever that is supposed to display.
Yes.
Or just can be that way.
Although we just name it as tablet and handset devices, it can be different orientation. So if you rotate device on the horizontal way, you just display like this. But once you change the vertical mode, you can just change the navigation in that way. So it doesn't really stick to the type of devices. It's about what we call the configurations. And the orientation is a part of the configuration. We're talking about that in our next sessions.
Okay.
Yes,
So as you said that about the
receiver.
broadcasting.
Yes.
So, for example, you can get the boot up this message
Broadcasting intent.
intent.
Yes.
Then, so if you want to get that intent to 2 different type of classes in one application.
Mhm.
So, can you actually change the order of the receiver? Which one is first and which one is later?
Well, in that case, I don't think there is a certain order to get notified by the intent resolver system. But what you can do is you just register the receiver and you call it by yourself. Like you just proxy the intent the receiver call, and then you just call 2 components that you want to be notified. Right? Then you can just guarantee the order of the notifications.
Otherwise, you can actually change.
We don't know which order the Android will notify.
I think great.
Yes.
Let me ask you some
yes.
quick questions.
Yes.
So when you develop an Android application, don't you usually target certain device, whether it's a tablet or a handset, like a phone?
Well, it depends. It depends on what we need, and we need to think of the more devices we support, the better it is, right? But then it's related to the effort and time, and that is the money, right?
But for example, in Apple's world, there are certain applications only support the iPad,
Yes.
right? So when you go to the App Store, there's a menu that you choose only for iPad supported application, or Android both, and then with download phone application iPad, it's working, but it's not
Stretched.
managed, right?
Yes.
It's stretched.
Yes.
Is it the same in Android?
Yes.
Or?
Yes. It's not exactly same, but it just works in the same way. You can just filter out like subset of devices by Android versions, or like in a many way, like by language, by screen size, or by region, or like some certain hardware specs, etc.
Alright. So what if you want to have like one application but targeting two, let's say market, one for tablet, one for phone?
That's possible.
Then you can have like a core as a service, and then like the user interface can be two different targets.
Yes.
Where tablet has more your area, so that you can use multiple fragments.
Yes.
Then when you build the APK, you can have like one for tablet, one for phone. Is that?
Yeah, that's also possible.
Or is
Yes.
it possible?
Yes. I think that's about how you set up the project, right? You just make some abstraction, like common module projects there, and you just make it as a reference to like another project.
Okay.
And when you build it, you just compile all together.
Alright. So when you submit your final outcome to, let's say, Android market,
Mhm.
do you like? Is there a way to specify this is a tablet only? Or?
Yes.
Yeah. Okay.
Yes.
So,
And even you can deploy two APK files with the same name. So say you upload two APK files. So in case device is a version below 2.3, for example, then this like APK A will be available for them. And then above 2.3, then like APK B. So it's really flexible to in terms of deploying the APK. You can just manage it in your code level. So you just provide all the fragments and the classes inside, and you just filter out by it fails, it fails, it fails. Or you can just totally delegate to filtering the feature, filtering the behavior on the Google Play Market options. But if you do it on your code side, then like overall the APK file will be increased, and complexity of the project will be increased. So I personally recommend just separate them, and then just maintain separately. So once you just decide to drop a part of the devices, so only just you need to do is just close the APK file, right? Because all the physical files are already separated by the different project. That's what we usually do.
Do you have any running application from the Android right now, public?
Myself, the
Yes.
application.
Yeah, or you and your team. So can you show your application?
Well, I have a few, like because
When you have a chance, I would like to
Yeah, maybe
your application.
okay.
emulator demo you can show us.
Well, the application that I'm working on right now is not for public people. So this is more like internal use. So you can't really use it. But the ones that I used to work previously is they haven't changed it like a lot. So it's not
fine.
really what I just made it.
I
but
want to
think-
understand the architecture or whatever. So
Okay. Yeah.
If you can.
Sure. So everything's good.
Yeah.
So we're gonna
Fine,
take a
great.
break a minute
Alright.
later.